Hello all, my name is Naveen Chilamkurti. I'm the General Chair for this conference, WiCON 2020. It is our great pleasure to welcome you to the 13th EAI International Wireless Internet Conference. Will be conducted online on 11th of December 2020. See, after organizing 12 successful conferences in various exciting cities in the world, in 2020, WiCON was proposed to be conducted in the most livable city in the world, that is Melbourne, Australia. But to just ensure the safety, comfort, and quality of experience, especially for presenters and successful course of this event, we must conduct all these presentations online live. This conference provides you an excellent venue to present your excellent results, innovative ideas, exchange some results, discussions, collaborations. And we have received many papers in different fields, especially connected to wireless communication security, IoTs, wireless LANs, industrial IoTs, P2P communications, software-defined networks, machine learning, and vehicular communications. The technical program is made up of contributions from the authors, which covers a wide range of topics such as blockchain, SDN, privacy and security in wireless communications, 5G radio sensing, support vector machine, and social network data. And the primary objective of this conference is to basically provide an academic and industrial professionals a unique opportunity to discuss recent progress and advances in various wireless communications. Of course, such meetings offer a chance for you to mingle with others, to discuss, exchange, to collaborate, to have some networking with your peer researchers around the world. And of course, the industry also will be more beneficial. We want to offer our gratitude to our co-chair and keynote speaker, Professor Abbas Jamalipour. He's well known for his IEEE communications. He's an ex-editor, editor-in-chief, and he has published many books, many authored, many publications, very high quality publications in the mobile and 5G communications. And we are very thankful to him to accept his keynote. And I would like to thank Professor Neeraj Kumar from Thapar University in India, Professor B.G. Kim, Sung Kyung Women's University from South Korea, and last but not least, Mahmoud Hamoud from Manchester Metropolitan University in United Kingdom. They all well supported, and suggestions from these people has made this conference possible. And of course, the conference cannot be more successful without help from various social media chairs, publicity chairs, workshop chairs, and other contributing members. I'm really grateful to them. Of course, least but not last, the authors who submitted their research, excellent quality research work. I'm very thankful to them too. And I would like to thank one of you all for participating in this conference. And I really wish you all the best. And hopefully next year we'll meet sometime in the city, exciting city, where we can network and exchange our results. I wish you all the best. And thank you for attending this conference. All the best.
Dear ladies and gentlemen, let me welcome you to EAI WiCON 2020 conference held in this virtual interactive setting. I am Karolina Marcinova, and I would like to address all of you on behalf of EAI and WiCON 2020. Unfortunately, I'm not able to meet all of you in person, so I'm using this opportunity to address the organizing committee, the keynote speakers, the authors, and the participants on behalf of EAI. I would like to thank all of you for being a part of this conference and for your involvement with EAI. In particular, I would like to thank the whole organizing committee for their hard and excellent work throughout the whole process of the conference preparation. Lastly, let me use this message to invite you to join us again at EAI WiCON 2021. Information about the next edition will soon be available on the website. Should you be interested in becoming a part of the next year's organizing committee or the technical program committee, please do not hesitate to contact me at my email address below. Similarly, if you're interested in discussing other possible cooperation, a conference, a workshop, or a new event altogether, please contact me at my email address as well. Now, my colleague Michal will present you what EAI does, who we are, and how you can get involved in our various activities. Thank you for your attention and enjoy EAI WiCON 2020.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, Or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Good afternoon, everyone. It is my great pleasure and honor to provide a keynote at the 13th WiCON 2020, which is happening in a virtual format in this year. My name is Abbas Jamalipour, and I'm a professor of the ubiquitous mobile networking at the University of Sydney in Australia. Today, I'm going to talk a little bit about the edge computing and aerial support in 6G wireless networks. Before starting the main topic of discussion, I would like to give some introductory statements about this talk. As we all know, the 5G cellular mobile wireless communications is being deployed at this time around the world in different countries. While we are waiting to see the full implementation of the 5G wireless, we are also researching on the issues that needs still to be done to improve the connectivity and the efficiency of these networks. The two topics that I'm going to discuss today are among the areas that are considered as being important elements of the future networks that might not have been completely implemented within the current 5G wireless standards. As usual, we need to get closer to the users, bringing them closer to the network edges in order to reduce the latency to the levels that we need for example, future applications like driverless cars and autonomous driving. In that sense, we also need to include some intelligence within the networks. There are plenty of intelligence in 5G networks, but those might not be as complete as we would see in the 6G networks. So the first topic of discussion will be the intelligent edge and fog computing for 6G networks. Later on, I will also talk about the aerial supports for example, including drones and LEO satellites that can provide a much better coverage for our future wireless networks. I believe these topics will be needed to be included in the 6G networks whenever they are being implemented. The agenda for my talk is first to give a kind of introduction to the road towards 6G wireless networks. I will then discuss about the intelligent mobile edge computing in general, followed by the aerial support, mainly the UAVs and drones inclusion within the wireless network infrastructure. I will then try to combine these two topics and give you some presentation on our works and research related to the aerial fog nodes. So let's start with some introduction under the road toward the 6G. So when you think about the road from 5G to 6G, and the way that we are going to travel this journey is that we will know that anything that we use a network connection for right now will be greatly improved on a 6G network. What are those applications and services that we are thinking about to receive and have a good efficiency for them in 5G networks? We have heard about the faster internet everywhere through the 5G. You have seen about virtual reality or augmented reality, AR and VR inclusion, and the application that we will benefit, that they will benefit from the 5G connectivity, the smart cities, and the better healthcare. So all these applications will be also included in 6G networks. So literally, every single improvement that we have seen or we expect for the 5G will manifest as an even better enhanced version in a 6G network. So it's all about providing a much better service than what we can expect from 5G in the future generation of the cellular or mobile wireless networks. So what we can expect from that 6G? Of course, it's very early stages and very early time to think about the standardization of the 6G. But what we can expect from that? Those are the things that will bring new initiatives and new innovations toward the 6G. What we have now under the 5G, or at least we expect we'll have after a good implementation of 5G around the world, is that we will have more powerful virtual reality and augmented reality systems. We will have interconnected smart cities and farms. We have artificial intelligence at our fingerprints. We will have intelligent robotics working in factories, car-to-car communication, and many other applications. So these are things that we are expecting from 5th generation mobile networks. So how about 6G? Later on, when we will have a 6G, 5, 10 years, who knows? We will continue to support all those areas. All those areas are important. So we will have to continue the support for those areas. But we also want to have an even better bandwidth efficiency that will ultimately expand the innovation even further. And maybe even it gets us to the fields that we have never tapped into yet or even considered them. There are many applications that requires still enhancement. We can think about the peer-to-peer communication, the personal communication that we have been talking about for the past 2-3 decades. These have to be improved in a much better way in 6G networks. Smart healthcare, another important issue or application for the future networks. We really need to get a much smarter healthcare. We are not simply trying to use the wireless communications to facilitate some doctor-patient communication. We really want to get more information about the patient's status, different conditions of a patient, pass on a doctor or an intelligent machine that can diagnose or cure the, for example, disease in future. And this requires much faster, much better bandwidth and much more reliability that we expect from 6G. Of course, we are getting some form of these applications in 5G networks, as we could get some through the even 4G LTE networks. But the 6G is about making everything much better. Another application, very simple, or can be considered basics, broadband, internet, everywhere. That is something that we really need to get in 6G networks. What we currently have is a kind of convenient internet communications everywhere. By no means is it full reliable and good communications that we expect. And 5G will not provide the complete global internet access that we need everywhere with the service and the efficiency that we expect when we are in the middle of a big city. So these are the things that we really need to have in 6G networks as enhanced applications. The 5G came as a new network. It was defined by International Mobile Telecommunication for 2020, or IMT 2020, and it came with different scenarios, as you know. Enhanced mobile radio broadband for human-centric cases and access to multimedia content, ultra-reliable low-latency communication, and massive machine-type communication. We have been promised to have 10,000 or more capacity, network capacity in these 5G networks, the speed of 10 gigabit per second, and the cell edge data rates of 100 megabit per second. And most importantly, the latency of less than milliseconds. Are we going to get all those things? Maybe not. At least not at the beginning of the deployment of the 5G. 5G provides different services, enabling new, secure, dependable, ultra-reliable, and delay-critical services for us. For cognitive object, and also for cyber-physical systems. It will include flexible and efficient wireless interface, access system, other enabling wireless network technologies. It even provides you with network slicing to provide a share of the bandwidth to the application that needs them, and different end-to-end logical networks. So these are the services, at least promised by the 5G. So how 5G can provide these services? By a series of techniques and methods, like a much better radio access technology, smaller cells, again, making users closer to the edge, the network edge. New spectrum in the order of tens of gigabit per second, energy efficiency, spectrum sharing, radio access network virtualization. So these are some of those techniques and pillars of this 5G new network. The coverage footprint of this 5G new network will include a combination of low and high bandwidths. So we will have basically 100 megabit per second for IoT and critical communications, which require full coverage. We provide 1 gigabit per second for example, through the massive MIMO and with LTE grid. And we provide much higher in the order of tens of gigabit per second for local capacity through the millimeter waves. So the coverage footprint of the 5G network will be from a small area to a very wide area network. But it will be through different technologies and through different spectrum bands. As usual, the 5G came as a result of the requirement of the high capacity applications or high capacity networks requirement. So we have been always looking at the increase in the data traffic that is created by the user and their applications. But still, we really wanted to provide a much better and safer and more reliable quality of service for all the users that are using this 5G network. But the most important element that differentiate 5G from its predecessor, like 4G or UMTS, is ultra-low delay services that it can provide. Why we don't need these? The application that require very, very low latency, but still they require very, very high bandwidth. The most immediate application that we can think of is the autonomous driving, the driverless cars. You cannot have a driverless car without very low latency wireless communication and very high capacity network. It must be very reliable network to provide low latency in the order of few milliseconds and also tens of megabit per second. Augmented reality, virtual reality that you want to use in different applications, like the healthcare, like the gaming, and many other applications that could be critical, and tactile internet. So these new services require an extreme low delay and high data rate metrics. And that's 5G will came about. So when you think about the 5G and 6G, what makes them completely distinctive from one another? Speed and latency will be still the clearest distinction between 5G and 6G. So when you think about this 5G, the fifth generation cellular network, it has done greatly in terms of the low latency. But at the end of the day, we would be lucky to get something around 4 millisecond latency in 5G network. The 6G might bring this down even further, the way that we even think about the virtual zero latency. That's a very important element that makes the 6G different and distinctive from 5G cellular network. And of course, the capacity. We may see several hundreds of gigabits per second, or even in the range of terabits per second for the 6G network. Those things are impossible to achieve in 5G networks. So 5G come up with different enabling technologies, like new spectrum in the areas that we even think about them, in the order of 40 or 60 gigahertz or higher, beamforming, network slicing, multi-connectivity. But one thing that we are emphasizing today is edge computing. It's one of the enabling technologies for 5G, which will be very important for the future networks, including the 6G networks. Don't forget the IoT, the Internet of Things, self-configuring wireless networks. We have been talking about the IoT for the past almost 5 to 10 years. What do we have right now is a very simple version of the IoT. In future, we will have basically everything connected to the network. And guess what? The IoT requires and needs the wireless to be connected. All these sensors, all these devices, all these applications that we are using on those devices, whether we as a human or the machines are using those, have to be connected through a very reliable, high-speed, low-latency wireless communication system. And the information will be stored over the cloud. Many of our services are provided over the cloud. So when you have this kind of requirement, you need a much better wireless system, something that 5G would not be able to provide. So we have started to see massive IoT cellular. So we have seen deployment of a massive IoT cellular network using, for example, narrowband IoT in different parts of the world, to especially address the diverse and evolving requirements for the utilities, smart cities, logistics, agriculture, wearable, and manufacturing, and so on. Also, we need to have much better connections for our public safety and disaster recovery systems that are coming through these IoT sensors. So this is a huge application that requires a very reliable, low latency, high capacity new networks. There are, of course, many challenges for IoT: massive scaling, architecture, data collection and storage, robustness, security, and privacy. But when we think about all these applications and that they will come over the cloud, we think about the computation and the storage as the main elements of the IoT and its challenges. We have already started to looking at the IoT 2.0. We recently submitted a paper on exactly this, as other people have been working on that. So in IoT 2.0, the IoT application productivity will be improved heavily. Its service quality with the user vision will be improved heavily. It will be an AI-driven service development. You will need interoperability, security, IoT connectivity, and IoT automation. So these are the new elements that enhance what we were thinking about of the IoT for many years, or at least for the past decade, but now in a much better way and much greater and extended way. And this requires a better network, and that's the 6G networks. So after this discussion about the 6G, let's talk a little bit about the intelligent mobile edge computing. As you know, and as we have been talking about the edge computing, it is about reducing the bandwidth usage and latency for the IoT network. For that, you will need to deploy machine learning on the edge of the devices. And this is something that brings more intelligence to the network. So edge computing would be an enabler for low latency and real-time AI applications. So different elements of the edge computing will relate to data sources, AI, and also actionable insights. When we think about the architecture of the edge computing, we can see some good and potential scenarios like fog computing, mobile edge computing, and cloud-led computing. Fog computing is nothing but an extension of the traditional cloud computing. But as fog is lower and closer to the earth than the cloud, the fog computing will also provide a much closer distance between the user and the network. And therefore, it can provide a much better latency response for the future networks. We talk about the mobile edge computing, which is designed for the cellular networks. And it utilizes both computational and storage capabilities. What we need from this mobile edge computing is a network which is flexible, low latency, and real-time services for our mobile end users. We have also heard about the cloud-led computing, another architecture for the edge computing, which is a virtualized server that is one hop away from the end user. So you don't have that distance problem that we usually have in the usual edge computing system or cloud computing system. This would be enable us to store provisional resources and to provide the end users with flexible, low latency, and real-time services. When we think about the cellular, traditional cellular radio access network, you see that we usually put this radio network controller or RNCs somewhere which can be central to most of the users within the core network. So they need to be large enough to serve multiple base stations. So in one sense, it is a kind of client-service networking paradigm, which creates long-distance traffic by calling and network bottlenecks. So what we had over the years was basically a kind of radio access network upgrades from our circuit switch network into the packet switch, then harmonization, then LTE. But at the end of the day, this kind of cellular and kind of basically centralized radio access networks, they have one common thing among them, and that's that all network traffic mass traverse basically servers located at edges of the core network, and that creates network delay and network congestion. So when we talk about the 5G, what did it do with its CRAN or Cloud RAN, or sometimes called as a centralized RAN? So 5G tried to fix that problem by the CRAN. So basically centralizing the radio access network, but putting it on the cloud. So this CRAN has usually three primary components. The BBU, which is a centralized baseband unit located at a centralized site, and it functions as a cloud or data center. We have RRUs, or remote radio unit networks, basic connecting wireless devices, and then fronthaul or transport network, which uses optical fiber communication or cellular communication or millimeter wave communications. When we think about this kind of new CRAN in 5G network, you will see that it can provide much lower cost of the ownership, improve network performance, reducing the network latency, not to need to have every time basically rebuild of the transport network, plus many other basically benefits like pool resources, reuse of the infrastructure, and simplifying network operation and management and so on. One of the things that we have seen in the 5G is the virtualization of the radio access network. Why is that? Because we know that the future networks must handle large amount of data that are produced from the IoT or other applications that we have discussed so far, or from high definition, for example, video content, or augmented reality and virtual reality. So one way that researchers come up with to solve this problem is basically by virtualization of the radio access network, something that we call it as vRAN. So moving toward that area, we can think about the fog to make us a little bit closer to the edges of the network. So we move from the cloud into the fog, a term that back in 2012 defined by Cisco. Basically, it's nothing but extending the traditional cloud architecture to the edges of the network, and that's significantly reducing the latency of the task processing. It can also extend the building blocks of the cloud, like computing, storage, and other network services. So we have been working about different ways that we can bring this concept of fog computing into the mobile network. One of the areas that we have been working and publishing 2019 in the IoT journal was a 3-tier mobile network, where we studied optimization models to reduce the energy consumptions and the delay of the network, while we are guaranteeing the energy balancing among all fog nodes. What we did was to find the optimal transmission power and basically transmission rate of the terminal nodes, finding the best fog node for serving the terminal node at any time, with the consideration of we want to guarantee the energy balance among all the fog nodes using topology potential. If you're interested, you can look at the mechanisms that we introduced, and we call it as EBA, or energy balancing algorithm for 5 fog IoT networks, in that basically IoT journal paper. Another work that we have done was, we call it association-free fog network, where we studied a new protocol where we could have the terminal nodes immediately broadcast their data with a certain transmission rate to potentially all fog nodes without the need of prior determination which fog node to associate. And then this fog node determine where to process the request locally or forward them, for example, to a cloud center. And we consider the fading channels between the terminal nodes and fog nodes, and we try to mathematically characterize the energy consumption between the terminal nodes and the fog nodes. That was also published in Transactional Green Communication Networks in 2020. If you are interested, you can have a look at this paper. We have been also working on finding a reliable loss-free fog network by finding an optimization model where it can find the best transmission power and best transmission rate of each terminal node based on the channel condition, because that is something that you always have in a wireless network. It's not a network with a fixed or stable channel condition. And this work, which was published in IEEE Transactional Wake Law Technology in 2020, resulted actually in improved network performance in terms of reliability and loss ratio, still maintaining the balanced energy consumption among volumes. So you see that there are plenty of activities that we can do to improve the edge computing and make them more intelligent and more effective in future 6G networks. One thing that is still we need is their coverage, actual physical coverage of the wireless networks. And we know that there are a certain basically physical limitations to the coverage of a base station, no matter what you consider them in a wireless network. So the next topic that we are going to discuss is about the aerial support and how we can include them in 5G and beyond networks. So basically these UAV or unmanned aerial vehicle base stations are coming as a kind of assistance to a normal base station in a cellular network. It is a promising technology with many traits, and it has a variety of integrated scenarios, like, for example, providing service when base station is damaged, for example, through a disaster, a natural disaster, or any other reason, like a power failure. It can provide additional coverage to basically a temporary event, like a sport event, or it also can provide a kind of wireless scaffolding. And because of the good coverage that this basically aerial base station can provide, you would be able to enhance the coverage of the cellular system. We're talking about the UAV, but you can have exactly the same kind of discussions and understanding with satellite systems, especially with low Earth orbital satellite like LEO systems. So why aerial platform? I think I mentioned most of the things because they are basically easy to deploy. They are easy to be removed from the system. They have a very nice line of sight communication, and you can easily control them. And they are getting much cheaper over the years. They can provide a good broadband communication basically very quickly. You can roll out and roll off them as you need and at a very short time. And the good thing is that you can use any of the technologies, whether those that we already have or any future technology for wireless network in these aerial platforms. So when we talk about the UAV or airborne assisted cellular, we can think about multiple of these ABS or aerial base stations that can support terrestrial base stations. But then we have to think about the interference that they may generate to one another. How they want to be switched from one, for example, one user from an aerial to a terrestrial base station and vice versa. So we have been working on these areas and how you can, for example, share the spectrum for them. One of the papers that we published in 2020 in IoT Journal about this UAV-8 cellular basically operation was about the offloading, cellular offloading. When you have an area which is covered by too many users and the terrestrial base station over there cannot support that, you can always fly one of these UAVs and try to offload basically the traffic. You can also reuse the spectrum between basically this terrestrial and aerial base stations. So in this paper, we have been working about optimization of this aerial base station altitude and transmit power, as well as the offload portion of the users, and try to find the optimal values for the design of variable that we have in our system. So you can do a lot of these things in improving your cellular connectivity. We have been working also more on the placement and the power allocations of these UAVs. For example, by designing 3D positioning of the aerial base stations and transmit power allocation for all nodes for uplink and downlink. And if you are interested, you can look at one of the works that we recently published in IEEE Transaction on Communications about this, where basically our objective was to maximize the weighted sum of the minimum data rates of the aerial basically users, those users that are connected through the aerial base station, and the minimum data of the users who are connected to the terrestrial base station, which basically involved basically in solving a non-convex optimization problem that we we try to solve with different methodologies. Let's now try to combine these two topics of edge computing and the aerial support in terms of aerial folklore. So when we think about the drones and how they can provide services to cellular network, it's not always the case that you actually bring new base stations and add to the infrastructure. You may be able to use or reuse some of the infrastructure that are basically for another purpose, basically in the sky. So in this work that we have published in IEEE Transaction on the vehicle technology, we have been looking at the logistic drones. You have heard about Amazon and all other basically providers that they are thinking about the use of drone to basically move and deliver the packages. So one of the things that we have been looking at is to use these logistic drones while they are actually delivering goods. They can also provide some service to cellular network in the form of the support to the cellular networks and to offload some of the traffic that usually goes to cellular networks, especially when it is at high demand in central cities where basically those logistic drones are flying. So we have worked on optimizing basically the trajectory and altitude of the drones in order to have, first, of course, deliver the physical parcels, but also to maximize the network capacity and reduce network interference. And it was interesting that in this work, we could result in some improved network throughput with minimum energy efficiency, energy inefficiency, and by when we are actually doing some detour paths to assist congested cells. So it's not that you always use the same pathway that you are using in logistic or delivery of the goods, but also sometimes you try to move a little bit around into another area where you know that it is highly demanded traffic of the cellular exists, and therefore you can out with the cellular network. And these are all emerging areas that could be considered as maybe a small but important pieces of the future 6G network. These are the things that we haven't even thought about in the past generation of the cellular networks. And for 5G, we have been always thinking that it will be on its own, whether through different technologies or different spectrum, but still it's on its own. But now you have these logistic drones and all other infrastructure that are for different purpose now used for improving the cellular connectivity and cellular spectrum or capacity. So one of the things that you can do is basically use these UAVs or drones as becoming actual fog nodes. So basically you try to create a cluster of the users which are connected to a drone, and these drones are the fog nodes that we have been talking in edge computing and fog computing. So for example, in a work again published in Transactional Vector Technology in 2020, we have been looking at this, studying the optimal assignment of the area of fog node to ground terminal nodes. And then optimizing the 3D placement, three-dimensional placement of the UAV fog nodes to improve terminal nodes, energy efficiency, and also the network delay. Just to have more fun, we have been also working to some side effects of these drones, because sometimes you have to recognize these drones compared to other flying objects like birds or airplanes and so on. So we have been doing some works based on the machine learning to try to detect and classify these amateur drones out of different sounds, as I mentioned, like birds, airplane, or thunderstorm, especially in a noisy environment. It may not be directly related to the cellular connectivity and improve the wireless communication, but it is something that you may need and you will need in improving this kind of element that we are adding to cellular network. That work was published in Transactional Vector Technology in 2019. So you might be interested to see how the machine learning can provide this kind of improvement to our drones communication. So I think I'll try to wrap up my talk by giving some closing remarks on what we have discussed in this talk. So thanks to the flexibility of the 5G radio access network and what it actually offers, the services it offers, we still can see there are plenty of accessories, I call them accessories, that can make it even better. Not just in terms of just the data rates and the delay, but make them more fun, make them more usable and applicable, more dependable, more autonomous. That's another thing that still missing in many of our wireless and especially cellular networks, and basically more ungrounded. So getting out of the earth and basically over the sky as we have in the UAV. So these are the elements that might seem minor or accessory, but they are indeed elements of the future 6G network. It means that we will see a new network, a much newer network, rather than a kind of evolution from one generation to another generation. So we will see many of these works, and of course, in any of these, you have to consider the edge computing and edge communications, making users closer to the network, and also basically improving the coverage and the latency of the future network. These are the things that will inspire the creation of the 6G wireless network. So we are at the time that we really need inspiration and different elements that will bring us to that new level of the network, not just an improvement or one generation after the 5G, that it is still the same old network, but maybe with some improvement. So that would conclude my talk. I would like to thank everybody who listened to this talk, and of course, the organizers of the conference, the WiCON 2020, for having me in this conference. It is a great pleasure. I wish we could be together in person and we could share better knowledge among us, but it is what it is, and we have to be all safe. So I wish you all the best, and I again thank you for listening to my talk. And if you have any questions or any thing that you would like to ask me, please send me an email, and I'll try to be quick in answering you. Thank you very much, and stay safe.
Good day, my name is Małgorzata Wasilewska. I'm a PhD student of Institute of Radio Communications at Poznań University of Technology. The topic of my presentation is spectrum sensing and prediction for 5G radio. The presentation agenda is as follows. First, I'll do a short introduction to the topic. I will explain why spectrum detection and prediction is important due to the evolving telecommunication networks and techniques. Then I will go over the basics of signal detection and how to evaluate the detection methods. I will talk about the system model that has been considered in the experiment, which will be followed by problem definition. And I will talk about chosen deep learning methods that were used for spectrum detection and prediction. I will also describe the baseline prediction method that was used for the comparison in the simulation. And last but not least, I will present the obtained results, and I will end my presenting by concluding. So the number of mobile or wireless subscription is growing constantly. This includes personal cell phones and in the future Internet of Things as well, devices. Recently, due to pandemic, there has been noticed a significant increase in data traffic, even up to 100%. So the 5G and future communication systems are expected to be spectrum aware and be able to reuse spectrum flexibly in order to maintain and improve the quality of service and spectral efficiency. The main issue of spectrum awareness, and especially spectrum occupancy awareness, is how to assure its highest accuracy and how to reuse the spectrum efficiently. As previous research proved, machine learning provides good tools for intelligent spectrum signals detection, and also is a promising tool for spectrum state prediction. Machine learning is especially useful for finding correlations in data. For example, patterns of signals in time, frequency, space, etc., which is exactly a case in telecommunication data. In the experiment, we considered a system with one unlicensed user, secondary user, that in order to reuse the spectrum holes in the future tries to detect and predict licensed user or primary user spectrum activity. So the detection process is about really choosing between two hypotheses, hypothesis H0 and hypothesis H1. The hypothesis H0 applies to the case when the received signal Y consists only of noise N. So there was no signal transmitted by the primary user in that case. The hypothesis H1, on the other hand, means that the primary user transmitted signal S that has been distorted by the channel H and then has been received with the noise by the secondary user. The detection algorithm is supposed to decide correctly which hypothesis is true. The prediction algorithm works on the same principle as the detection algorithm, but the decisions concern future signals that has not been transmitted or received yet, and the decision is made based on the current received signals. The evaluation of detection methods consists in determining two probability values, namely probability of detection, PD, and probability of false alarm, PFA. Probability of detection is a probability that the algorithm correctly detects the present signal, and the probability of false alarm is a probability that the algorithm detects the signal even though it is absent in the spectrum. So it means that probability of detection detects the signal while the hypothesis 1 is true, and probability of false alarm detects the signal although the hypothesis 0 is true, so the signal is not present in the spectrum. And generally, we want to maximize PD so that in case of secondary user's transmission, the primary user transmission is detected and protected. At the same time, we want to minimize the probability of false alarm so we can maximize spectrum reuse. As mentioned before, we consider a system with one primary user that transmits the signal to multiple users. There is also one secondary user that wants to gain information on current and future spectrum state. We consider the WDM signal in the form that is compatible with LTE in a special case of 5G signals as well. Secondary user corrects energy values per of WDM symbol in a given time slot and tries to use this information for spectrum detection and prediction. So here is the difference between detection and prediction. The main issue with the detection is that it only provides information on the current spectrum state. And after the detection, there is really not a lot of time left for transmission before another round of detection is needed. So the answer would be to use prediction. But the main issue here is that it's actually quite difficult to find a good method for predicting future spectrum state. The solution proposed in our paper is to use deep learning, which is known for its intricate pattern recognition and finding complicated dependencies in the data. In order to test the algorithm, 2 data sets have been generated using MATLAB. Here is the first data set. The first data set is emulating daily traffic changes typical in the communication data. The scale in here is, of course, not really kept. Here we see time in seconds, really, while in real data, such changes would rather appear during days. But for simulation purposes, such an assumption was made. So on the x-axis, we see time slots, and on the y-axis, there is a frequency. The yellow areas are where the signal is present in the given time slot and frequency, and the blue areas are free spectrum holes that could be potentially reused. We can see a correlation in time of this data. There are some repetitions which are justified by the fact that the same resources are probably assigned again to the same user if it needs resources again. The smallest unit of signal in time and frequency will be referred to as a resource block from now on. The second dataset considered is for the situation where there are some sensor signals present which are highly correlated in time, although not perfectly, as we can see on the A figure. Over the sensor signals, some random signals were transmitted, as we can see on the B figure. So the B figure is the one that shows the signal that was actually used in the simulation. The first algorithm that has been tested for the spectrum detection and prediction is a neural network. Its input data per resource block consists of frequency index, time slot index, energy of this resource block, and energy or sum of energies of the neighboring resource blocks. Here are some details and the proposed architecture. 3 dense layers have been used, followed by the softmax layer. The main problem here is that the neural network can only decide on the status of one resource block, the present one on one or one of the future ones. In the experiments, we needed to predict status of 1 current and 6 future resource blocks in the same frequency. So at the end, 7 neural networks were implemented in order to do that. Next algorithm is a recurrent neural network. It is known for its abilities to predict time series, so it should work well. As an input, it receives a time sequence of 100 elements consisting of 3 values. Again, time, energy of a given resource block, and energy of neighboring resource block. So again, sum of energies. RNN is trained separately for every frequency, but it is actually able to predict next 6 time step spectrum status simultaneously. So we gain information about 7 steps really, because we can have a detection and prediction for 6 time steps at the same time. And the last algorithm is CNN, so the convolutional neural network. As an input, it receives 2D images consisting of energy, information, and time and frequency indexes as well. And its most important advantage is that it is able to predict and detect spectrum status simultaneously for 7 time steps and for every frequency considered at the same time. So at the output we have like an image also, which consists of a decision about each resource block's status. In order to correctly evaluate the algorithm's performance, the baseline detection method has been evaluated, called primitive prediction, and it uses detection results of a currently considered machine learning and assumes that all resource blocks for a given frequency in every future time slot will have the same occupancy state. So it basically means that it repeats detection result as a prediction, which can actually be a good prediction method if it signals for signals with high signal density over time. So if a signal is pretty much always present, then this prediction is actually really good. And in highly in a wireless networks with high traffic, it's really true. It's a true case. Here are some results for first dataset and for neural network algorithm. So the blue lines are the results for probability of detection, and red ones are for probability of false alarm. And we have results for prediction equal to 0, which means the detection, and prediction equal 1, which means that this is the prediction for the next time step. Prediction equal to means that this is a prediction for the second time step, and so on. For low SNR values, neural networks algorithm is able to achieve probability of detection equal around 50%, which with keeping lower values of probability of false alarm around 20%. For prediction and detection, the results are the same in low SNR, but for high SNR equal to 12 decibels around, there's a visible difference between prediction results for each prediction step. The more detailed analysis can be found in the paper, of course. And here are some results for the RNN. For low SNR, the difference between PD and PFA is much more visible than for the neural network. The gap between those values is around 50%. So this is actually a very good result. And the prediction probability of detection plots improved comparing to the neural network results as well. So you can see that prediction works much better for RNN than for neural network. The CNN results were expected to be better than RNN, and it is true, although it may be hard to see on the slide. This will be explored in more detail further on. At first glance, they seem to be very similar. Here we can compare the results of probability of detection and probability of false alarm for all of the deep learning algorithms and their corresponding for prediction time steps and for their corresponding primitive prediction. We can see that the neural network achieves lowest probability of detection results and highest probability of false alarms, so which is exactly the opposite that you wanted to achieve. And primitive method based on neural network also performs the worst. The RNN and CNN are quite similar, although there is a higher difference for probability of false alarm values in results of the CNN. And here's the final results evaluation. It takes under consideration how the algorithms perform compared to the primitive algorithm. So you can see that neural network is generally the worst algorithm, although it does perform significantly better than its primitive prediction method for prediction step 5 and 6, although it's just because the primitive detection is so bad there. The best results achieved are for the CNN method, which performs best actually for prediction 3 and 4, comparing to its primitive method. We can also see that it's better than RNN at the end. So it's probably most beneficial to implement CNN. Similar results were obtained for the second dataset, and due to the time limit, I must refer to the paper, everybody that's interested. But just to present the final evaluation, here is the final bar graph that shows even more significant superiority of CNN algorithm over the other two algorithms implemented. So you can see definitely that CNN is better. So here we actually we can see that the results are better if the bars are higher, both for probability of detection and probability of false alarm. Just to conclude, 3 deep learning algorithms for detection prediction were considered for 2 different data sets, and CNN turned out to be the best one. Comparison with their primitive method was also performed in order to evaluate if they're actually useful or not, the deep learning algorithms. And promising results and room for future research is definitely present. I hope that I will be able to work on that further, especially that I'm interested in using the achieved results for actual spectrum reuse. Thank you very much for your attention.
Dear listener and manager, our work carried on towards preventing neighborhood attacks, proposal of a new anonymization approach for social networks data. Dear managers, our presentation will revolve around the following 3 points. Firstly, we will present the context and then discuss the issue. We also list some social network anonymization approach. Secondly, the solution will be present and also use tools. The result will close this part. Finally, we will conclude and then some track for future works are discussed. We present here a new anonymization approach to counter neighborhood attacks, which aims in relation to existing approaches to preserve the structural properties of anonymized graph. The solution is to adopt the K-neighborhood model to ensure that any individual can be identified correctly in the anonymized social graph with a probability greater than 1/k, where k is a parameter specified by the user wearing the same characteristic of the K anonymity model. So, for each vertex belonging to the graph, it will exist at least k-1 other vertices having neighborhood isomorphic. To define the information protection problem, personal wide publishing network data social protection against neighborhood attack, we need to formulate the following 3 questions. 1. To identify private information to be preserved or protected. 2. To model the basic knowledge that an adversary can use to compromise life private. 3. To specify the use of published data from the network social so that the anonymization method can try to retain the usefulness of data as much as possible while preserving private information. So, relying solely on adding links may not be a good solution to keep data useful. Consider the following original graph and suppose that the structure of communities can be detected from friendships in the social network and that node 6 and 8 are members of 2 different communities in the graph. The main objective of our work is to protect the privacy of individuals represented as vertices in the social graph. By connecting nodes 6 and 8, these communities can become very close or merge to form a single community. So, count only the adding links can be a good solution to preserve the usefulness of data. By adding link, we get a 2 anonymous network. To solve the problem, we suggest for preserve the important properties of graph, such as than the distance adding false node in the graph, in simply adding a false node to the previous graph we generate and a 2 anonymous neighborhood graph. Some anonymization approach technical for preserving privacy in database. The K-anonymity model proposed by Samarati and Sweeney. The L-diversity model proposed by Mashanavai Hala and all. 2. Technical for preserving privacy in social network. We have approaches by modification of implemented graph by Binzu and all, and the clustering-based approaches. We have the K-degree and no-degree model, the K-candidate model, and the K-automorphism model. Our approach, we propose a new efficient algorithm of anonymization called Anon's social network, which combine 1. The principle of adding link. Secondly, the principle of adding false node. We also offer the main solution following a new cost calculation formula anonymization to determine the neighborhood of somite that can be anonymized together. So a comparison of the performance of the approach proposed addition of false node compared to zoo and pay approach according to the preservation of the APL. The architecture of our anonymization approach is illustrated in the following diagram. In input, we have an original graph with the property, social property APL diameter and radius, and the output we generate an anonymized graph with the same properties. For the realization of our application, we opt to the following development tools: Windows 7 as an operating system, Java language as a language, the language of programming, NetBeans version 7.2.1 as development environment, Jiffy as a tool for the representation and analysis of social network, Pajek as a data generation synthetic tool. According to the figure above, on all set of anonymized data and other data set, the value of the APL measured on the graph anonymized using our unknown SN algorithm are very close to those of the original graph. Numbers also show that this property is better preserved using our algorithm. So the following figure shows the change process of the APL value of the graph according to different value of K. The vertical axis value before and after anonymization, and the horizontal axis represent the variation of the anonymity parameter K. The decrease of the value of APL is due to more the number of add link between the nodes of the graph is bigger. More the distance between the nodes decrease. In conclusion, in this paper, we have presented and analyzed the result of our proposed social network anonymization tools, which consider the distance between nodes compared to the Zoo and Pay algorithm. The result indicates that our algorithm preserves the mean distances compared to the existing algorithm because we add edges between the closest nodes, and if this addition does not preserve the mean distance, we add also nodes that maintains this distance close to those of the original graph. We have shown that our tool gives satisfactory results according to the test carried out. It makes it possible to remove the changes in the distances between the nodes and thus better preserve the APL structural property of the anonymized graph, which will be more useful for data analysis. Measurement of APL. We measure the APL according to different value of the anonymity parameter K to confirm whether anonymizations could avoid degrading the accuracy of analysis by changing the distance between nodes. Specifically, we aim to maintain the value of APL in an anonymized graph by comparing it to its original social network graph before anonymizations, as this preserves the usefulness of the data for future analysis, and we were able to achieve this goal. Our different experimental results demonstrate that the algorithm combining the addition of false node with the addition of link can obtain better results compared to that based only the addition of link, and it can generate a graph that effectively preserves the property APL. At the end of the work, future extension and perspective are envisaged to improve it, namely, deal with the case of Z greater than 1 when the attacker has basic knowledge about the neighbors of the victim at Z terms. It would be interesting to reduce the number of add false nodes, in other words, to study the number of add false vertices. We also plan to study other network structural properties to further improve the preservation of utility in social network anonymization. Consider the implementation of this model in a graph with sensitive label by introducing the concept of L diversity to prevent homogeneity attacks and better protect sensitive label while preserving structural property. Thank you for your kind attention.
Good morning, ladies and gentlemen. First of all, please let me express our sincere thanks to the conference. Thank you very much for participating in this conference, sharing our paper and studies your excellent papers. We feel very lucky and benefited a lot. We are from the beautiful Yulin, the hometown of Wang Li, the Chinese linguist, educator, translator, essayist, poet, and one of the founders of modern Chinese linguistics. We are from the Yulin Normal University. Yulin Normal University is located in Yulin, the hometown of famous linguist Wang Li, an excellent tourist city in China, and Yulin City, a 1,000-years-old ancient city in southeast Guangxi. Welcome to our beautiful city Yulin, to our beautiful campus, Yulin Normal University. The topic of our paper is research on the user privacy security of country's top 10 online game platform. The title of the paper is consistent with the research talk of this conference. We all know that with the development of the Internet in the 21st century, online games and online sports have become an important means of leisure and entertainment of teenagers. In China, a common phenomenon is that online games are popular at all ages, from primary school students to the elderly. Online games can be found. Online games are very popular, and the problem of online games are constantly revolved. The security of online games have become a frequently seen issue in network health, liability disputes, and network service contract disputes. In the network infringement of people's rights and interests, online games require game users to agree to its formal terms as a promise to obtain user information. But the protection of game users' privacy is not entirely a prominent problem of online game security. The promise of users to register of access to online game platform survivors is to accept to user agreement and privacy policy provided by the platform. The content of these agreements is usually to permit clauses prepared by online game companies in advance, which involves disclosure of personal identity information such as the user's name, ID, email, address, head photo, and so on, to which to have access to the survivors. User can only passively hit the agree button to accept the terms. However, online games companies often focus on economic interests and ignore the protection of users' privacy rights. As a result, the identity information of game users is easily leaked, which will undoubtedly lead to the damage of users' privacy. Involved of this common phenomenon, our paper analyzes how to standardize the permit terms of online games so as to protect the privacy and safety of game users. In the process of writing this paper, we used to research methods of literature analysis, quantitative analysis, and case study. I will explain the reasons and the process of using these methods one by one. As the name suggests, the literature analysis method is to research and analyze the collected monographs, papers and conference reports related to the topic. This analysis method is a very convenient, free, safe, and free investigation method. Our team has divided the use of literature analysis research method into two stages. In the first stage, we first searched and downloaded a large number of internet and law in CNKI. After that, the team members quickly load the literature within the agreed time range, extract useful information from the conducted literature and analyze it. Each of them puts forward a paper title. Finally, after group decision and teacher's guidance, the topic is finally determined. In the second stage, we define the connection of literature based on the determination of the topic, in addition to the literature analysis method. Quantitative analysis method and the case study method also runs through it. In the early stage of writing, we group inquired about the user privacy agreements of the top 10 online game platforms at home and abroad, and then classified the contents involved in the privacy terms of the 10 platforms to form a complete table. Finally, through one-to-one comparison, we marked the existing and non-existent contents in each platform terms to obtain the final data. The above three synthetic research methods provide great support for the writing of the article. Literature analysis method allows us to broaden the scope of reach in limited space and time. Select 10 respective online game platform privacy articles for analysis. Improve the accuracy of the study. Finally, use quantitative analysis method for comparison to provide a guarantee for the accuracy of the article research. The paper studies the privacy protocols of the top 10 online game platforms in China, such as Good Old Games, Oregon, Steam, Apply, WeGame, Blizzard Game, Nintendo, Sago, and NetEase, in order to understand the privacy and security issues of Chinese online game platform users. For example, in addition to Winam's reference to restriction on the use of real hierarchies of measures, and such information is not prerequisite to use services. Additionally, these platforms share a feature, that is, users' information may be changed by cookies. Moreover, cookies are not bound by privacy agreement, so users' information cannot be guaranteed after being used by a third party. The abuse of identity information of users, especially for minors, may lead to the infringement of their privacy rights. If their information is leaked, it may be purposefully conducted by lawbreakers, subjecting minors who have to mutually development physically and psychologically to mental damage. Through the data these of the user agreements and the privacy protocols of the 10 welcome game platforms mentioned above. This paper finds out the problems existing in the privacy information of game users and the protection measures of users' privacy. According to the specific contents of the privacy agreement and user agreement, the paper analyzes in main body of online game platform supervision and the game platform. The solution and protective suggestions are put forward in the aspects of DRAM platform, hope to help protect the privacy of Chinese game network security basis. Through literature analysis, quantitative analysis, and case analysis, it is found that the use of mobile phone number and email address is the promise of users to accept the platform survivals in Chinese 10 most popular online game platforms. Good Old Games, Oregon, Steam, Overline, WeGame, Blizzard War Night Square Game, Nintendo, Sango Game, and NetEase. Users who want to use any game must agree to the user agree and privacy agree of the game. The privacy agreement and user agreement are not the result of the prior agreement between the game user and the game platform. The privacy agreement and user agreement are the format terms that have been drafted in advance by the game platform and likely before the game users buy the game. The content of the format terms is mostly to benefit the game platform terms for the establishment of user information. Protection system is not very perfect.
There are many innovations in the articles written by our group, of which two are the most prominent innovations highlights. First, the research object is correct and intuitive. In the related issues of Internet protection, the public's vision will focus on the protection of network, virtual property, and infringement of network service providers. Well, we will focus on the protection of network platform privacy. Privacy protection of network platform involves all aspects of daily life and also involves people of different ages, especially minors. Focusing on the privacy protection of network platform can find the problems existing in the terms of network platform service providers and promote the attention and protection of minors by this society. Therefore, it's of great significance to take the protection of network platform privacy as the research object in order to ensure the value and feasibility of the article. We collected the privacy agreements of the top 10 popular game platforms in China and interpreted, summarized, compared, and analyzed the terms of each platform. Finally, the article showed the mobile phone number, ID card, email address, date of birth, avatar, password, username, geographic location, name of each platform in the privacy terms. The date and the conclusion are intuitive and specific. In the selected network platforms, they are both Chinese and foreign. Their concretization, visualization, and typicality of the research objects can fully show the status quo of privacy and security of online game platforms. Second, the uniqueness of these stories. In the process of data collection, people usually use the methods of investigation, observation of research objects, and extraction from literature. However, we collect the privacy protocols of the top 10 game platforms through the official website of online game platforms, in addition to the common collection methods. The privacy protocols of their official websites are open and transparent, and are specified in the form of text. At the same time, looking at the terms of the privacy agreement of each official website, there are many provisions that will make specific settings for the specific situation of the game platform. For example, if it's found that children's personal information irks or may be leaked, damaged, or lost, the network platform will immediately start the emergency plan, take remedial measures, and take the incident. The rules of informing the affected guardians and children by email, letter, telephone, push notice, announcement, etc., and the terms of information guaranteed or shared by users when using the third-party partner service may be obtained by network platform. The comparison of these detailed terms can make us easily find the defects of some game platform privacy protocols, and even more, it's helpful for us to put forward targeted suggestions on privacy protection of online game platform. So, the data collected from the official website is an important basis for this analysis, and also a major innovation of this article. The author thinks that the current online game platform is insufficient to protect the user's privacy while using the user's information. Therefore, the author puts forward specific options under information security protection of online game platform from 3 different subjects, so as to better realize the protection of network users' privacy. First of all, the regulatory body proposes to limit and level management measures for the contents of user-identified information collected by network platforms, and strictly formulate access mechanisms for foreign platforms and restrict cross-border transfer of personal information. Secondly, it suggested that online game platforms should strengthen the refinement of standard terms, set the minimum reading time limit for standard terms, and should set the options in the format terms. The emphasis is to reduce unnecessary format terms, which are beneficial to the platform. At the same time, it advocates that the platform should require the minimum age of game users. Users should use real name and ID card for face recognition, and face recognition should be carried out regularly in the later use. Moreover, there are restrictions on game time and real name authentication. Registration is required. Finally, the author suggests that users should change their concept of negative power and enhance their ability to protect personal information. In addition, it also emphasizes that minor users should use online games cautiously and reasonably to avoid unnecessary property loss and personal information leakage and other security issues. The above is the main content of our research. Thank you for listening.
Hello, my name is Shadi Abu Dalfa. I am an assistant professor at the University College of Applied Sciences. It's my pleasure to present our paper, which is titled as Hybrid Deep-readout Eco-state Network and Support Vector Machine with Feature Selection for Human Activity Recognition. This work is conducted in cooperation with Professor Kevin Borchard from Leiria Lab in University of Quebec at Chicoutimi. This presentation contains introduction, background, a description of our solution approach. I'll describe also an environment used to conduct our experiment work. Then I'll show some result and finally conclude the paper. As an introduction to this work, nobody can deny effect of healthcare on societies nowadays. And it's worth mentioning here that one of the most important tasks used with healthcare systems is referred to as human activity recognition. This task is involved in such systems by collecting data from some sensors. Then the data is transferred through wireless networks to healthcare systems. These systems may be also connected to internet to support some Internet of Things services. This means that any improvement in this area will result in an important impact on a large range of domains. Mainly, this task is achieved by employing machine learning techniques, thereby using sophisticated machine learning techniques reveal a significant improvement in human activity recognition. This encouraged us to explore performance of employing more machine learning techniques with the human activity recognition. The general framework for human activity recognition consists of some phases. The first phase is based on collecting data from some sensors. Then the next step is based on extracting feature from collecting data. Finally, one of classifiers should be used to classify feature vectors, which is referred to as data points. The output of this system will be activity labels. Thereby, each data point will be mapped to a specific class of activities. Now I'll describe our solution approach in details. Of course, firstly, we need to collect some data from some sensors. Then we should extract some feature from the collected data. After that, we applied feature selection to improve accuracy of activity recognition. We also applied data scaling for normalizing attribute values. Our main contribution is based on merging eco-state network with support vector machine to improve accuracy of activity recognition. To merge both models, the presented technique applies ESN to the normalized data. Thereby, ESN will provide logits corresponding to data points. Then the presented technique will apply support vector machine to the same normalized data, and the output of support vector machine will be probabilities of prediction correspond to same data points. Finally, the presented technique will use both probabilities and logits to make final decision. Of course, the output will be activity labels. To show performance of the presented technique, we conducted numerous experiments. The environment used to conduct experiment work is based on using Python language. We used two machines to conduct the experiment work. First of them is a local machine, while the other one is a cloud supported by Google. We conducted our experiment work by using a dataset entitled Activities Exercise Recognition. This dataset includes 1,150 data points. This dataset is collected by Kevin team from L'Area Laboratory at University of Quebec in Chicoutimi. This dataset is collected by using inertial central units. This team designed a device for collecting this data. The dataset includes 10 classes of activities collected from 10 participants. For example, this activity consists of 2 steps, and the second one clarify how to measure step down activity. The third one describe the activity of sit down. And so on. And this table shows a set of features used with the dataset. To show performance of the presented solution, we used a tool to visualize the dataset. We can see in this figure that the classes are unclear, but after applying feature selection, we can see now that the classes are well separated. So applying feature selection is a good process. Also, applying data scaling will improve the performance through normalizing attribute values. We also evaluated performance of ESN since it is a main component in our presented solution. This table shows a list of hyperparameters used for training ESN model. We also built a comparison framework for comparing the presented technique with other models. We compared our presented technique with support vector machine. We compared also our presented technique with ESN model. ESN model is composed of reservoir networks and a readout layer. Due to large number of hyperparameters used in ES model, a total of 500 random configurations are evaluated. Of course, using larger number of random configurations may reveal the global optimum values, but we didn't investigate this matter further because it is a time consuming. We also compared the presented technique with an extension of ESN network, which is titled as bidirectional deep reservoir eco-state network. This network based on using reservoir network. Then it uses principal component analysis to reduce number of dimensions. And finally, there are some layers of multiple layer perceptron. And of course, the output will be activity labels. This table shows a list of hyperparameters used to tuning bidirectional ESN. We can note that there are some intervals used to tuning these parameters, and these are the best values selected to tuning the parameters. We also compared our presented technique with another related work entitled ESN Support Vector Machine. This related work is based on using reservoir network, and the output of the reservoir network is used as input to support vector machine, and finally the output of support vector machine used to predict activity labels. So we can see clearly that this related work is different in using another technique for combining ESN with support vector machine. They use ESN and support vector machine as sequential process, but our presented solution is based on using both of ESN and support vector machine as parallel. This table illustrates the output of our comparison framework. In this comparison framework, we used tenfold validation to make the comparison fair enough. We can note that our presented technique outperforms the other models. We can note also that in each fold there are competitive results provided by the presented technique. Thereby employing the presented technique with human activity recognition is a promising research direction. We also make some experiment to compare time complexity of these models. We can note clearly that the presented technique provides competitive results in comparison with bidirectional ESN and related work entitled ESN Support Vector Machine. To sum up, this work evaluates performance of applying eco-state networks with feature selection to human activity recognition. We also present a technique for improving the performance of a human activity recognition. The experiment results show that performance of the presented technique outperforms performance of support vector machine, ESN, bidirectional ESN, and a related work entitled ESN SVM in terms of classification accuracy and F1 score. As future work, this research can be extended in different ways. For example, evaluating the presented technique by using more reservoir computing models, applying more feature selection methods, using optimization methods for finding optimal values of hyperparameters used with the presented technique. Of course, applying optimization methods will improve performance of the presented technique. Thanks for listening.
Ladies and gentlemen, it's a great pleasure to be here with you. Today I'm going to introduce my paper, Performance Evaluation of Energy Detection, Matched Filtering and KNN under Different Noise Models. The authors are Wang Xiaoyan, Yang Junjing, Yuteng Ye, Li Rui, and Huang Ming. My presentation is divided into the following 5 parts. The Part 1 introduces the research background. The Part 2 explains the research purpose. The Part 3 describes the research model. The Part 4 analyzes the research results. And the last part summarizes all the paper. Right now, let me introduce the research background. As you know, the amount of Internet of Things devices based on wireless cellular network architecture has been increasing explosively with the advent of the 5G era, which will not only bring convenience to our daily life, but also bring greater consumption of mobile bandwidth, putting forward a higher requirement of radio spectrum safety and making radio monitoring particularly important. Due to the broadcast nature of radio transmission, both authorized and unauthorized users can access the network, which leads to the increasingly prominent security problems of wireless network. At the same time, there are many electromagnetic interferences in complex environments, resulting in many monetary data accompanied by uncertain non-Gaussian noise. It is more difficult to detect and identify users in wireless network environment due to the influence of noise. So, that brings us to the part 2, the purpose of the study. We have 4 research targets over here. Target 1. We are trying to find an effective way for radio spectrum management. Target 2. We studied and analyzed the performance of detectors under ideal conditions and took it as a baseline. Target 3. We want to know what is the difference on performance of detectors between Gaussian noise and non-Gaussian noise. Finally, we want to find out what is the effect of uncertainty to the detector noise variance. Then, the research model will be shown in part 3. In our research, 3 kinds of noise are given to analysis. As you can see, Gaussian noise, Laplace noise, and alpha stable noise are shown in figure 1, which have the probability density function as figure 2. For the Gaussian noise, it has a state of standard normal distribution. The alpha stable noise has an obvious peak. Laplace noise has a heavy tail. Here, we are going to introduce 3 detectors. They are energy detection, matched filter detection, and detection based on KNN algorithm. For energy detection, it only focuses on the energy value of the detected sequence, and after receiving, the energy statistic is calculated and compared with the threshold. Channel is busy when the energy statistic is larger than threshold, otherwise the channel is free. Fig 4 illustrates the process of matched filter detection. Assuming that the signal received by the matched filter is Xn. The output of the matched filter is denoted as Yn, and the energy statistics is compared with the threshold to determine the state of the channel. Unlike the first two methods, KNN algorithm based on machine learning is a supervised learning algorithm, which needs to build training set and label. 5 depicts a process of method-based KNN algorithm. The energy statistics are calculated from radio signal Sn and labeled as 1. For noise Wn, the energy statistics are labeled as 0. In this way, we build a training set that includes data and tags, then 70% of them are used as training data, 25% used as testing data to evaluate the performance of KNN. Here, Tn is a sample signal to be tested, and Euclidean distance is used as a measure distance. Distance between the energy statistics of Tn and each sample in the training set is calculated. Then, key samples that is closest to the TT is selected to calculate the number MO and M1 of TW and TS. Finally, the sample under test will be labeled as a category with a larger number. In order to analyze the performance of different detectors, we assume that the channel state information is fixed, and we assume the value of CSR is 1. The signal sequence is BPSK modulated signal, and the noise sequence is established according to the SNR. Clear case of parameter configuration in the experiment is given below. Part 4 is about research result. Different detectors are used for the signal interperiod by Gaussian noise under different SNR and found that energy detection and matched filtering the best performance under Gaussian noise. The detection probability of KNN is the best, with the increase of false alarm probability, the detection probability of energy detection and matched filtering is also increasing. Under the same false alarm probability, detection probability of matched filtering is much higher than energy detection. In order to figure out the performance of the detector under non-Gaussian noise, we conducted a large number of experiments and compared the results with those under Gaussian noise. The performance of both energy detection and matched filtering decreased under the Laplace noise. Under the alpha stable noise, the detection performance of matched filtering improves rapidly, while the detection probability of energy detection decreases sharply. In addition, the detection probability of matched filtering is higher than energy detection, which shows that matched filtering has higher flexibility than energy detection in dealing with different noises. KNN has the highest detection probability under different noise. When the noises are non-Gaussian noise, the detection probability is maintained at 1. In practice, the noise is uneven and time varying, which causes the variance to fluctuate in a certain range. Analysis of the influence of noise uncertainty on the performance of 3 detectors under different noise. The simulation's results in Fig 9 show that whether Gaussian noise or non-Gaussian noise, Once there is a small uncertainty in the noise variance, it will cause a great change in detection performance. As a result, the detection performance of energy detection and matched filtering decreases. Matched filtering has a stronger ability to resist the uncertainty of noise than energy detection. KNN has a detection probability of 1 under non-Gaussian noise. Finally, we will make a summary of the above work. A large number of simulation experiments were carried out to evaluate the performance of different detectors under different noise models, and the results show that number 1. KNN is not sensitive to noise uncertainty, and the detection probability stays at 1 when dealing with non-Gaussian noise. Number 2. The detection probability of matched filtering and energy detection under Gaussian noise model is higher than that under non-Gaussian noise model. Number 3. Under Gaussian or non-Gaussian noise model, matched filtering has a higher detection probability than energy detection. Matched filtering holds a better performance to resist all kinds of noise. Number 4. Considering the uncertainty of noise, the detection performance of matched filtering and energy detection declines no matter what noise model. Number 5. Under the same noise uncertainty, matched filtering has a better detection probability than energy detection. Matched filtering holds a better performance to resist the noise with uncertainty of variance. That's all I want to share. Thank you for your listening. If you have any questions, please feel free to contact us. We will be happy to solve the problem with you.
Hello all. My name is Naveen Chilamkurti. I'm the General Chair for this conference, WiCON 2020. I'd like to close this welcome with a round of thanks for everyone who made this WiCON 2020 possible. I'd like to start thanking my fellow members of the organization committee and all the chairs, co-chairs, and all the people who are responsible to run this conference, especially EAI, which has actually organized all the websites, all the submission systems, all the associated selections, and some sponsors too. Thanks to our keynote speakers and all the authors who presented during this conference. And I wish you all the best. And hopefully we'll meet sometime in next year in a different city. EAI conducts a lot of conferences, and I wish we can all, come together sometime, for exchanging some research ideas, basically. And of course, finally, I would like to end with a special thanks to all the people behind the screen, behind this entire organization, to come up with various new ideas. And as I said before, unfortunately, this year is exceptional due to the, due to this difficult situation. We had to do everything online. Otherwise, we would have been enjoying a meeting with each other, collaborations, new networks, and so on and so forth. But nothing is lost. We still have years to go. I wish all the best, and very good luck for you all for future endorsement. Thank you very much.